Hi, everyone. This is Jody Shivo speaking. And Jake, thank you for that introduction. So, folks, I am the VP of Multi-Channel Marketing for Autonomy. And joining me today is Corey Kim, and we're very lucky to have Corey today. Corey works for one of our key partners, Digihas, and Corey has some practical expertise dealing with implementing and best practice around LiveSite. So today what I'd like to do, if I look at my agenda, is quickly go through a summary of LiveSite, and that's for the folks on the phone may not be familiar with some of the capabilities that are within the product and how that actually plugs into existing team site implementations. What we'll do then is hand the discussion over to Corey, and what we wanted to do is to have Corey speak to true life experience with LiveSite, give you some examples of implementations, and also give you some best practices around how one would implement it, and basically things to be aware of in implementation. As we close the discussion, we'll go over a hardware topology architecture, which is very, let's just say, similar to what you might do with any LiveSite implementation, and we'll step you through that. During our discussion, if I can ask you please to put any questions you may have in the QA console on the WebEx, which is in your lower right-hand side. And what we'll do with that is we'll collect the questions, and what we'll do is there are contact information at the end of the agenda, and then we will do our best to get those answers to you as quickly as possible after the web conference is over. Now, what I wanted to outline with this slide is what we're seeing is the marketplace for what's traditionally known as web content management is evolving. And basically the products that Autonomy provides is evolving as well. So what we're seeing is typical web content management as depicted on this slide. Certainly the traditional product team site provides that functionality. I think everyone on the phone is very familiar with that. But what we've done now is added different requirements around, looking at the bottom of the slide, media aggregation. What we're finding is most people want to be able to publish and manage content that's not stored in TeamSite. That can be from other systems, from broadcast news, from social media. So basically the foundation of our solution that's outlined in this slide is our IDLE product. And I think most of you have heard about IDLE. We'll talk about a little bit in our discussion here. But it allows TeamSite to go after third-party enterprise content and bring that into the TeamSite system for editorial review and ultimately publishing. As we look up the slide, targeted experiences, I would say I speak to many of our install-based TeamSite clients, and many are looking to create personalized and dynamic websites where the site visitor comes and that site is specifically tailored to their needs, their requirements, or it's personalized based on marketing rules. And TeamSite and LiveSite do provide that functionality. And finally, and once again, we're seeing this more and more, is multi-channel, where this content that's personalized needs to be delivered to multiple websites, multiple devices, and multiple channels. So the nice thing, the two top elements of this is really where LiveSite provides huge value in allowing us to create these really personalized custom websites targeted at an individual, and also then delivering this personalized content to any device, any application, or any website. Now, just to refresh folks on the phone, the elements of the solution, and it's very important to come away, this is a modular architecture where these elements can be deployed separately or basically in concert, as you see in the slide. If we start with TeamSite, I think most people on the phone with TeamSite, as you will probably all know, we've released 7.3 of TeamSite most recently. There was a DevNet webinar about 2 months ago reviewing the new functionality, including the new UI. The site publisher tool is the WYSIWYG authoring environment that's been available for TeamSite, and really the state-of-the-art authoring tool for any type of content management deployment with TeamSite. Barrage Media Bin is our rich media asset management system. And Barrage is nice because it does store those assets, but it also allows for conversion of those assets into different formats. As an example of that might be mobile. And then finally, LiveSite, which is our topic today, which is sitting outside the firewall, which is really two layers, a data layer and what you might call a content rendering layer, which dynamically assembles the website based on the individual or based on personalized rules created by the marketing person or discovered by IDLE. And needless to say, IDLE is the foundation of all of our products, provides things as simple as search, but also provides really very advanced things around personalization and content integration. Now, if we drill down a little bit more deeply into it, LiveSite then is the ability to take content from TeamSite, which is typically published statically, and create a page that's assembled specifically for a user, really truly creating a dynamic experience. Now, we can do that with rules that are created in TeamSite, more or less if-then-else rules. But more interestingly, we can actually use idle to profile the user as well as profile the content to really provide very rich personalization capabilities. Now, LiveSite also not only allows us to really render and publish the content dynamically, it also provides a mechanism for integration. LiveSite allows us through idle to integrate with over 400 different systems, which ultimately allows us to publish and produce content from third-party systems, from enterprise systems, or for social, have that come through LiveSite and ultimately get published out to a website or a mobile device. And as an example, and this is very straightforward, but the notion of a dynamic experience allows me to use the same content to create multiple website experiences based on the user. And needless to say, repurposing that to a mobile device or a mobile application is inherent in what LiveSite does. So the reality is, behind the firewall, the marketing person adds the content once, applies the appropriate personalization rules, uses idle for personalization as well, and creates a unique experience depending on the device, the user, the site, the channel that the user comes to the content on. Now, drilling down a little bit more deeply, is LiveSite is broken into two elements, and this is actually really, really important. LiveSite comes in LiveSite Content Services, which is really the data layer, which stores the content within the idle repository outside the firewall. Also, LiveSite Content Services has the rules engine, which is really the personalization engine that allows us to target the content specifically to a user, a site, or group of users. LiveSite is broken into a separate element for display services, which is truly the rendering engine, which allows us to develop a whole site or portions of a page of a site and have LiveSite really handle the rendering of that, which allows us to apply these personalization rules and assemble a fully fledged website or portion of a website. Drilling down more deeply is at the API level. This architecture provides our clients a very unique way to integrate both any type of application from a portal to Java-based applications to .NET. It allows us through LiveSite Display Services to really be responsible for rendering the page or portion of the page and having LiveSite manage that. Alternatively, we can go directly to content services via REST API and pull the raw content out of the system. So this type of architecture allows our clients, and we're seeing this, and Corey will review this as well, is giving the flexibility to enter the content once, enter the personalization rules once, but be able to target any website, any device, any application with personalized targeted content. Needless to say, too, idle as the foundation, it's indicated on the slide, provides all these connectors that we can bring in enterprise content, social content into LiveSite Content Services and display that through display services or deliver it through the REST API. So if we look a little bit more deeply in each element here, so content services is the data layer, and it is not relationally based. It is based on idle, which means that the IT folks on the phone aren't burdened with rows and table in the relational database. Idle will dynamically adapt to changes in the content, to the type of content, the tagging of the content, basically open deploy issues to put the content into LiveSite Content Services and provides out-of-the-box integration. Now, once it's there, the content is available to any application, to any portal or rich internet application, and basically allows us to deliver that content dynamically through REST or dynamically through LiveSite Display Services. Now, LiveSite Display Services is the rendering engine, and that allows, as depicted on the right-hand side of the slide, to render a portion of a page, for example, a portal or a JSP, or it can really deliver the entire page. So this really gives the web designer the flexibility to integrate to any type of existing application, and also allows us to control things like primary site, microsites, and landing pages, where really the control of the page might be dictated depending on what the marketing person is trying to do. So with LiveSite Display Services, certainly one of the biggest advantages here is personalization and assembling a site based on rules that are stored in TeamSite, or rules or really things that idle discovers that will allow us to personalize the experience specifically to the user or group of users. LiveSite has native capabilities to support both J2EE as well as .NET, And we also provide out-of-the-box portal integration with our Omni Portlet, which allows things like Oracle WebLogic, or IBM WebSphere, or LifeRay to natively integrate into this platform and allows LiveSite Display Services to deliver content. And finally, obviously this is very, very important for many people, both support of Java and .NET. So LiveSite Content Services, the data layer, will support the REST API, and it allows us then to integrate both technologies. And basically, once again, allows us to accommodate any type of changes in IT infrastructure over time, whether it's moving from Java to .NET or vice versa, and we don't need to change the content or change the personalization rules or change the underlying infrastructure. Now, what I'd like to do is hand the phone over to Corey, and Corey is one of our key implementation partners here at Autonomy. And Corey has been involved with TeamSite for over 5 years and very closely involved with many of our marquee customers in moving their traditional TeamSite implementation to LiveSite. So Corey's going to give you an idea about some best practices, some examples of what people are doing with the product, and then what we'll do is I'll take over again and wrap up with kind of an overview of a typical topology for deployment of LiveSite. So what I'd like to do now is hand the phone over to Corey. And Corey, I think you're on the line for us.
Hello, everyone. Thank you, Jody. My name is Corey Kim. I'm the principal at Digit House Corporation. We've been doing LiveSite implementation since the inception of LiveSite as a product. We did, in fact, the very first implementation of LiveSite, which was internal to Autonomy Interwoven, and we've done some of the most complex, some of the most highly visited sites, LiveSite implementations to date. Today, I'm going to cover 3 topics. First, how to drive your own site redesign or refresh with LiveSite. Secondly, to provide some examples of what other people are achieving with LiveSite. And then finally, some implementation considerations and best practices. So when it comes to driving your own site redesign with LiveSite, there are basically 2 approaches. There's the forklift approach and a greenfield approach. And in my experience, roughly half of implementations will use each. So the forklift approach is one in which you already have a very mature implementation of TeamSite, in which case we would reuse existing DCTs. So frequently you already have DCTs that are sufficient to produce a web experience, and we simply want to repurpose them for LiveSite. In order to do that, we take the existing DCTs, create new LiveSite components, and page templates for each presentation template. So sometimes we'll take a presentation template and convert it to a full LiveSite page template, and that will be served as a page. In other cases, a presentation template is used to produce essentially a reusable chunk of HTML, and in that case, we will use the DCRs directly inside of LiveSite components. Then we have a couple of different options for binding those DCTs to LiveSite pages. So we can either go with a static approach or a dynamic approach, and also a combination of both. The static approach basically creates static references between components and DCRs at the page level. So if you have, for example, 100 DCRs that are used to render 100 pages, then you would create 100 LiveSite pages with components that correspond to those DCRs, and then just create a static link from the component to the DCR. Now this allows for a relatively easy migration in that there isn't a lot of complex presentation logic, and also the pages themselves. The pages themselves can be built with a very analogous model to the existing website. So if you know that there's a given URL, you also know that that the component, that there is a LiveSite page responsible for that URL. The second approach is to render the DCRs dynamically. So we can do this a couple of ways, but essentially we would deploy the DCRs to LiveSite Content Services. So the DCRs themselves are deployed along with all of their metadata, and then the metadata is used to target DCRs to pages. Now you can either use targeting rules to target the DCRs to pages using the targeting feature, Or you can take the metadata and create custom query classes that will allow you to just programmatically query DCRs and render the results dynamically in LiveSite. So some advantages of the forklift approach. Primarily, you will potentially have a faster time to market because you're reusing an existing content model and simply changing the front end rendering system, replacing it with LiveSite products. And similarly, you would have a lower overall development effort, and you would reduce new training requirements on content producers. Potentially, there are content producers that have been spending years producing content using TeamSite, using the DCTs that are in place at the time, and they would continue to enter the content in the same way, but those contents would be delivered dynamically to LiveSite at the runtime. Some disadvantages. One is that legacy content is not usually a good fit for future business needs. An example is that frequently DCTs are designed so that they correspond to a given look and feel, a given page template. Unfortunately, what that can mean is that you have multiple DCTs that essentially are about the same content, but have different fields purely because of the way that they're being rendered. For example, you might have a field in a DCT that specifies whether it's on the right side or left side of a page, and that kind of information is not necessary in a LiveSite implementation. So one thing that we find ourselves doing is, in fact, using just the portion of the DCT that is relevant to the content model and ignoring any parts of the DCT that are specific to presentation, and then allowing LiveSite's own rules to override those. Another disadvantage is often legacy features and functionality have to be reproduced in order for the forklifted site to maintain the same functionality. An example would be for DCTs that have specially coded content, for example, hashtags or other kinds of symbols that are decoded at the runtime. So naturally, if these are custom hashtags or custom symbols that are decoded at the runtime, then LiveSite would also need to duplicate that functionality. And so it's very important to thoroughly understand how the legacy runtime consumes CMS content. It's important to thoroughly understand how the legacy runtime retrieves the DCRs. What are the exceptions? How can that logic be overridden? How is the content of the DCR transformed into HTML? What are the exceptions to those cases? And it's important when doing the forklift approach to look for custom functionality that may not be applied. For example, you might find that you have over 1,000 pages that are essentially the same because they're all product catalog pages. But then you'll find that you have a few pages that are web forms. And it may be that nobody was aware that those pages existed and that those web forms are dependent on the legacy runtime. So it's important to find those bits of custom functionality. Another note I'd like to make about the forklift approach is that it is applicable not only for customers who have a mature TeamSite CMS in place, but also for customers that have their own, another kind of CMS in place, whether it be a homegrown CMS or another vendor's implementation. In which case, what we would do is we would take the content from the CMS, whatever that CMS is, and then either use screen scraping or use other APIs to generate DCRs based on the legacy content. So the forklift approach is very powerful. It's highly recommended when essentially one is trying to overcome limitations of the existing runtime without changing the user experience radically. The other model, the greenfield approach, is more appropriate when a new user experience is desired. In the case when the user experience is being completely redesigned, there's a strong potential that any existing content model would no longer be relevant for the new user experience. Similarly, existing page templates, existing rendering logic would most likely become irrelevant for the new user experience. So in that case, we would go with a different approach. We would create a new content model from the user requirements. We would design new DCTs, but this time we would design them with the assumption of LSCS, LiveSite Content Services. And what that basically means is that we would know that there is a separation of concerns. We would know that the DCTs need only store the information about the content model and nothing about the presentation. And then a common practice that people use with DCTs is that they create direct associations between DCRs via a file browse interface. And instead, when you're using LSCS, you would want to use a taxonomy to associate DCRs. So for example, if you have one DCR associated with many other DCRs, then you would associate them via some taxonomy. So, for example, related topic, and you would associate the DCRs with that topic in the taxonomy rather than having direct linkages from many to many DCRs. Then, when it comes to rendering these DCRs, you would design content rules where appropriate for business requirements. So if there is a need, and there often is, if there is a need for business users to be able to design content rules on the fly, then you would do that using the targeting and content rule system inside Publisher. But often, and in fact, it's typically the case, that for core functionality, that you would create custom LiveSite content service query classes. Essentially, you would use the LiveSite Content Services API and create basically simple Java classes that have the queries built in, that get query parameters from the session context or from the request context, construct a query, dispatch that to LiveSite Content Services, retrieve the relevant content, and then pass that on to LiveSite Display Services for rendering. So some caveats when using the greenfield approach. So first of all, I find that one is much more successful if the solution design begins with an ontological approach, essentially beginning with the concept of what exists in the solution, what concepts exist in the system, and taking that ontology and decomposing that into technical deliverables. It requires a different mindset because often team site architects are used to the idea that if I have a different page type, then I'll create a DCT for that page type, and that is something that one would want to avoid, especially when using the greenfield approach. So I'd like to move on to what others are achieving with LiveSite. So one of the sites that we've been working on, one of the implementations that we've been working on is actually going live in about a week, is an extremely targeted content site. So you see the diagram where you have a page that's decomposed into multiple content blocks, and each distinct content block is populated with targeted content at runtime. Content is targeted based on a number of rules: the brand, the content type, template type, page, and block ID. And each content block is targeted with content that has scheduled start and stop times, so that on any given hour, any one of those content blocks can display different content. Each individual content block is populated by a single DCR at runtime. The component skin is defined by runtime. So, for example, block 4 might be rendered as a flash on one particular hour, and then another hour of the day it becomes static HTML content, and then another hour of the day it might become a dynamic JavaScript-based picture slideshow. This particular implementation supports hundreds of distinct pages and supports millions of users. And it's highly performant. The performance target is 100 requests per second. Another model that can be accomplished, and this is something that actually that we're incorporating with LSDS, and also implementing independently of LSDS, which is client-side targeting with AJAX. So if one would use LSDS and AJAX together with LSCS, you can change to a hybrid model where, for example, the header and footer, and then maybe some more of the Chrome around the page is defined using LSDS, and is essentially a static page. And then you have a component that basically functions as a content grid. The component includes a small amount of markup that initiates an AJAX query to LSCS, and then produces highly targeted content. So we have an example. So one implementation that we have is where this highly targeted content is a large number of marketing offers. There could be thousands and thousands of marketing offers that apply to different people, different users based on their location, their household, and the system is able to provide high performance by rendering page container statically using LSDS, and then doing all of the targeted content dynamically. In the case of AJAX targeted content, again, one DCR can be associated with each element of the content grid, and the difference is that the DCR will be consumed by JavaScript rather than by LSDS. The component dynamically lays out the content based on business rules and user preferences. So it could be, for example, that the AJAX component simply displays a 3x3 grid. It could be that the AJAX component has pagination. It could be that the AJAX component has infinite scroll. And the runtime never really has to care. The AJAX queries can also be edge cached, which is very helpful. So rather than having to cache a different version of each page for every conceivable customer segment, you can construct the query such that large swaths of customer segments are cached at the edge via the URL of the query. So some applications for this are highly targeted promotions for individuals, customer portals, and employee portals. And I actually like to do a demo of both an LSDS and a POC of an AJAX targeted site. Okay, so this is one of actually the first LSDS implementations. This is for Dow Chemical Corporation, and they had acquired a company called Rome and Haas. It was also a chemical corporation. Now, Dow was already a TeamSite user, but they were using TeamSite in the traditional way, where DCRs were transformed into HTML, and then navigation was being generated via presentation templates, and the entire experience was delivered statically. When Dow acquired Rome and Haas was using LiveSite Display Services, using essentially the forklift approach that I outlined. Dow actually adopted for their entire product site the LiveSite Display Service approach that they had acquired with Rome and Haas. So we have a navigation that's based entirely on metadata. We have this entire page is hosted by LiveSite. We have basically static components to handle the top navigation. We have some static HTML for the main content body. You can see that there's a little bit of in the recently viewed products list. There is a little bit of personalized information that's actually managed via JavaScript and cookies. And then we have some promotional content that is essentially targeted from DCRs on the right. As I drill through, I can drill through the content model. So the transportation industry, we go to different sub-industries. Now, what's interesting is that each industry and each of the sub-industries are dynamically generated, such that essentially 95% of the page of the content of this site at least the products and services portion of the site, is being served by literally 3 pages. So as I drill down from the industry through the sub-industries, the system is making queries, and then finally showing available products. This is filtered by the country of the user. And then finally, we can go to the description of an individual product. Actually, I'm sorry, that's an override of a landing page. I'm going to try a different product here, and I'm reaching another landing page. So I'm going to actually switch to a different industry. All right. So I'm actually finding a lot of product overrides, but the essence of the point is that all right, here we go. This is a product page that's driven entirely by a DCR. So we created a product DCR that has in various tabs actually the different information that's necessary, and LiveSite is surfacing different aspects of the DCR based on the user request. And we further have calls to action. These are integrated with SAP. And similarly, if you go to My Account and log in, and you have an account with Dow, then this entire experience becomes personalized via our integration with SAP, such that you can have also custom landing pages that filter the products and product lines based on the business that you do as a customer of Dow. I'd also like to show next a POC of purely an AJAX model. Now this is going to be, we're going to begin implementation of this actually in about a week. So what you're seeing is purely a POC, but it shows an example of the power of LSCS plus AJAX. What you're seeing here is essentially an employee portal. This will be incorporated within a larger LSDS page, but this can be implemented purely in a standalone website. You see that you have multiple content blocks. Each one of these is defined by a DCR. So for example, the New England Journal of Medicine RSS block is defined by a DCR that simply contains the details of the RSS feed. The applications block on the upper left is defined by a DCR that simply contains a list of links. So you have basic DCRs that are familiar to anybody who's been using TeamSite, but being rendered in a completely different way. Now, one of the advantages and strengths of using creating a rich AJAX application is that you have then the ability to do dynamic client-side actions. For example, the ability to drag and drop and reorganize the user experience. So with each one of these drag and drop placements, the system would make an AJAX call to LSDS and store the new geometry in the customer profile, in the LiveSite user profile for that user. And similarly, we could minimize and maximize content. These portlets, naturally, since they're being requested by LSCS, a TeamSite content producer would simply add a new department, and then the next time this page loads, the department would appear. So this is an example. We're going to commence development of this very shortly. This is an example of the AJAX experience that's made possible with LSCS. Another interesting feature that we've created. So one of the famous functionalities of LiveSite is the ability to get in-context preview and edit site content. So one of the challenges, though, with in-context preview and editing of site content is, and this is with any runtime solution, is when the content is dynamic, how do you get an in-context preview? How do you get an in-context preview that's relevant for different customer persona and different times of day? So what we've done is create an overlay where basically each component, so the site itself is configured with a property that basically turns display mode to preview. And then each component renders not just its HTML, but a snippet of JavaScript, some JSON, that contain some informatics about the component, how it arrived at its content. And then we have a panel that allows the user to change the context of the preview, changing the date, changing their logged in state, changing various aspects of the content. Secondly, we have overlays for each content block. For example, we have content rules defined by business that say that under these conditions, we want to display to the content producer a warning. And then as we hover over content, we can display content details, such as what the start and end date for that content was, what the priority was, and then create a link to allow users to edit that DCR, and also create a link to add new content to this page. Wanted to talk briefly about some implementation best practices. I touched on this before, but I'm going to go into a little bit more depth, which is that when you're defining your content model, and this is particularly germane to the greenfield approach, when you're defining your content model, you want to start with ontology. So on the top, we have basically the concept of ontology. It's the business concepts, what the relationships are, how one concept links to another, and then we take that ontology and decompose it into UML static structures. And then finally, and this is kind of an interesting step, you can take those UML static structures and trivially implement abstract classes in Java and then create XSDs from those abstract classes. And then those XSDs can be used to define the structure of the DCTs. Now, this is not an automatic transformation. One would still have to create the DCTs in the traditional way. But knowing that the DCTs conform with an XSD then allows for some powerful things later. Another practice that we found to be very successful is to create a business layer REST service. And we know that LiveSite Content Services is a RESTful API. It makes it very easy to integrate with for external applications. And naturally, LiveSite Display Services has native integration with LSCS. But we find that it's useful to create a business layer REST service. And we use JAX RS, and we create very thin service provider classes. And then we also use those the abstract classes that I mentioned in the previous step. We use the LSCS client library to do all the heavy lifting, actually retrieving the content based on a key or based on query parameters. And then we have the option of either returning the content results directly, or we can marshal the contents to internal model objects. So some of the benefits of working this way is that you're providing a REST API that uses business semantics rather than vendor semantics. So for example, you can have a URL specifically dealing with a particular content type and particular actions you can perform with that content type. The LSCS API is extremely generic, such that you have to declare the content type as a parameter, for example. Additionally, you can restrict and control access to the LSCS API. So for example, if you have thousands and thousands of DCRs deployed to LSCS, an LSCS query has the ability to return all of those DCRs as a result of a RESTful query. So you want to prevent potentially people from doing that and getting all of the content. And you do that by creating a subset, exposing only a subset of the LSCS API within your own business layer REST service. And finally, I mentioned in an earlier slide, it allows the API to be tuned for edge caching. So for example, if you have a key or if you have parameters that specify the query but are also reproducible and cacheable, then you can have the edge, for instance, Akamai, cache the entire query, and as far as it knows, it's just static cacheable content. So going a little further, debugging and testing LiveSite content services. So if you're not familiar with the command line utility curl, you should learn curl. It is truly your best friend. So, for example, LSCS, when you're doing development, you'll find that you'll frequently want to change how LSCS indexes your content, which means that you have to drop the existing index. And you can do that with one simple curl command to tell it to delete a project, and then you can use a script to then redeploy content. Similarly, if you have queries that you already know you already know the URL and you're expecting that they should work, you can use curl to do a spot check of the query to see what content is being returned. And that exposes LSCS's behavior at a very low level. Also, I would say that it's important to create JUnit test cases with LSCS. So you can actually just use the standard java.net API and construct the query as a URL, and then simply test against certain assertions from LSCS's response. It's also possible to create JUnit test cases against the LSCS client library, although in order to do that, you have to do some Spring integration in order to make it work. It requires more effort, but it does in some cases pay off. And then another final point I wanted to make about best practices is string-based versus object-based queries. And this is similar if you've ever programmed with Hibernate or JPA, you have a similar you have similar alternatives. You can create queries using strings and just do string manipulation to build up a query and then finally issue that query. Or you can use an object-oriented query where you're creating criteria, you're programmatically setting filters and comparison operators against fields and values. So the string-based queries are simple to get started, especially if the queries themselves are not complicated. However, when the queries become more complex, so for example, if you have nested Boolean conditions, that's really the strongest reason, it becomes useful to use the object-based query approach. And another nice thing is you see the snippet of Java below. I have methods that build attributes or that build constraints. And it's much more easier to do that using the object-based approach. And then the search terms are also much more clearly defined in code. You can tell instantly, looking at the code, that somebody is using the equals operator versus the substring operator. So that concludes my discussion of LSCS, and I'll hand it back to you, Jody.
Corey, thank you for that. And folks, there are a few questions on the Q&A board. Please feel free to put those questions in, and we will get those answers to you. What I wanted to do as we wrap up is go over what a typical implementation from a hardware perspective would outline. So what we see here is basically behind the firewall and outside the firewall. Behind the firewall on the left-hand side of the screen is the typical team site deployment with OpenDeploy. Not necessarily surprising. I think the thing to come away with is that in the development environment, depending on the circumstance from a QA development, you may actually have some additional servers there that actually deploy elements of LiveSite. And you would obviously have those in place for development, but also for performance testing. Since the LiveSite system is dynamically rendering the site, it's certainly important to test that, to test load balancing, and to test overall performance of the system. On the right-hand side of the diagram is, as we've outlined before, LiveSite is broken into two components, content services, display services. They are both multi-tier architectures, which allows us, as you can see by the slide, to create a content rendering layer, which is display services, one or more, probably minimal 2 servers, that allow us to load balance the performance and the user load across those servers, all sharing a single repository to display content. Then on the slightly left of that are the content services layer, which basically is where the data is stored, and as I mentioned before, the personalization rules. That's available through the APIs provided with LiveSite, through LiveSite Display Services, as well as obviously the REST API. Now, depending on circumstance, as you probably all know, idle is included with every product that we sell. But once again, depending on personalization requirements, search requirements, a separate idle server for site search recommendations and also for integration into third-party systems like social media, broadcast news, whatever the use case might be. Our slide depicts yet another set of servers, which are idle servers, which allow for high availability, but also allow this whole infrastructure to hook into those other sources of content as opposed to providing full site search for the site that we're managing in this diagram. Now what I'm going to do then is our final slide, which basically, Corey, if you go to the next slide for me. I think there we go. So what I'd like to do, folks, is that if you do have questions, certainly put them in the Q&A box, but also you can follow up contacting Sarah or Nicole directly. And please reference the webinar title as you see outlined there. This webinar will be put on DevNet shortly, and as you probably all know, there is a series of recent DevNet webinars we've put up, including the 7.3 team site overview. And those will be there from a historic perspective, so if there's any folks that might be interesting, you certainly can access them there. Once again, we'll give you a few more moments to ask additional questions, and once again, we will follow up on that. But I appreciate everyone's time. Any feedback is appreciated as well. Additionally, topics for future DevNet webinars would be appreciated as well. And that's it. I thank you all very much for your time. Corey, thank you very much. And Jake, thank you for running the call for us.